Hello and welcome back to our higher mathematics topic on straight lines. Today we're going to be looking at the intersection of lines and how to see if lines intersect each other. So when we say lines intersect each other, this simply means that the lines cross each other. So if we have a line, let's say this line here, and we have another line, let's say this line here, we would say that these two lines intersect each other, and we would say they intersect at this little focal point right in here. So the point at which they meet is called the point of intersection. And we say that these two lines, whatever they are, we say that they intersect each other. Now, when we do questions about intersection of lines at higher, we might get asked multiple questions, but one of the particular questions is asked to find the point at which two lines intersect. And when doing this, we must have both equations of the line before we do this. So let's say we have two lines, and we'll say that the first equation of line number 1 is 3y equals x plus 15. Now note that this is not given in the general form, but this is still an equation of a line. It's fine to express it in this form. And we'll say that the equation of the second line is y equals x minus 3, And in this question, or in this example, we are going to find the point at which these two lines intersect each other. So the lines are going to look maybe something like this, and we're trying to find the point at which one line meets the other line. Now there's actually a variety of methods we can use to find at which these lines intersect each other. However, we know that the points will intersect each other at the same x coordinate and the same y coordinate. So what we are doing when we find the intersection of lines, or the point of intersection, is we want to work out an x value and a y value at which these lines meet each other. Now the first way we can do this is by doing a bit of simultaneous equations, which we learned at National 5. So if we take this line here 1, and we take this line here and call it 2, and we rewrite them out like this, 1 and 2, we want to get it, so we've got 3y equals x plus 15, and we've got y equals x minus 3. How can we eliminate one of the terms y or x? Well, in this case, we can just subtract both equations from each other to get that 2y is going to be equal to, because we did 3y minus y is 2y, and x minus x is 0. 15 minus 3 is going to give us 15 plus 3, which is 18. So therefore, y must equal 9. Now we can substitute the fact that y equals 9 into one of our equations. Let's just go for equation 2 because it's a little nicer. We're only working with one y value. So we've got that y, which is 9, is equal to x minus 3. Add 3 to both sides. We get that x is equal to 12. And this is the first method for working out x and y. So we say that the lines intersect at the point 12, 9. So this is our first method for working out the intersection of two lines, and this is by doing simultaneous equations. We call this process elimination. The next method we're going to look at when working out the intersection of two lines, I'm going to use the same lines that we talked about before, is that we can do a bit of equating. Now, the way equating works is we want to make one subject, so in this case the subject is y, in this case the subject is y, we want to make one subject the same. Now 3y is not equal to y, however x is equal to x. So if we can get both equations in terms of x, this will be helpful for equating the equations to each other. So in this case, let's take our first equation and we'll work out what x is. So we'll change the subject to get x. Well, we just subtract 15 from both sides. So we get x is equal to 3y, subtract 15. And in this case, we get that x is equal to y plus 3. So for our first line, the equation is x equals 3y minus 15. And the second equation, we've got x is equal to y plus 3. Now, because we know that x is equal to this, and x is also equal to this, we can say that this is equal to this, correct? Because we have that x is both of these. So we equate. That's what we call it. We call equate because we are equating the two equations equal to each other. So we say that 3y subtract 15, which is our x in our first equation, is equal to y plus 3, which is also x in the second equation. So now we can use this and do a bit of algebra to solve for y. Let's subtract y from both sides and add 15 to both sides all in one step. So we're going to get 2y is equal to 18. And then we just solve again to get y is equal to 9. And now that we've got this, we can substitute y into one of our two equations to solve for x. Let's go for this one over here. X is equal to y plus 3. We get that x is equal to 9 plus 3. So x is equal to 12. And just like we did before, we found that the lines intersect at the point 12, 9. So this is our second method we can do for finding the intersection point, and this is by equating both equations to each other. So it's very important to start by getting the lines in terms of x on its own or y on its own. We could have rearranged these equations by multiplying this one by 3 as well. Now our final method of working at the point of intersection, so this is another way of doing it, is we can do a bit of substitution. So we know that y is equal to x minus 3, and we know that 3y is equal to x plus 15. So we can substitute the fact that y equals x plus 3 into this equation here. So let's say what we're going to do in this third case is we're going to substitute y equals x minus 3 into the equation 3y equals x plus 15. So what do I mean by this? Well, we know y is equal to x minus 3. So if we substitute that into this equation here, we get 3 times x minus 3, because this is our y. We've told that y is this. This is equal to x plus 15. Now we expand the bracket. We get 3x minus 9 is equal to x plus 15. And we just want to solve for x here. So we can take away x from both sides to get 2x and add 9 to both sides to get that it's equal to 24. And then we divide by 2. We find that x is equal to 12. And we know this is right from our other two examples. And then all we have to do is just substitute x equals 12 into one of the equations. Let's just go with y equals x minus 3. So y equals 12 minus 3, which equals 9. So again, we say that the lines intersect at the coordinate 12, 9. So this is our third method. We've looked at equating, we've looked at simultaneous equations, and we've now looked at substitution. So we'll do a few examples to round off the video, and it's actually completely up to you which method you use to find the point of an intersection. So here the example says find the point of intersection of the lines 2x minus y plus 11 equals 0. Now sometimes in cases there will be easier ways to do it. So in this case here I've got 2x's in one and 1x in another. I've got 2y's in one but minus y in another. So I'm not going to use equating, and I don't think I'll use substitution either. I think in this case here, I'll do a bit of simultaneous equations. So in this case, what we'll do is we'll try to eliminate one of the terms. So our first equation is going to be 2x minus y plus 11 equals 0. And our second equation is x plus, it's not a very good plus, sorry, plus 2y minus 7 equals 0. How can I eliminate the y's? Well, I can just simply multiply the first equation by 2 to give us 4x minus 2y plus 11, won't be plus 11, it'll be plus 22 is equal to 0, and we'll keep the second equation the same. We'll get x plus 2y subtract 7 equals 0. And then all we have to do is add both equations together to get 1 plus 2. So we'll do 1 plus 2, and this will do 4x plus x is going to give us 5x minus 2y plus 2y will eliminate the y's, and 22 plus minus 7 is plus 15 equals 0. We can solve for x here. 5x is equal to negative 15. So our x is going to be equal to, divide both sides by 5, minus 3. Now, as we do with simultaneous equations, to work out the other one, we just substitute the fact that we've worked out that x is equal to minus 3 into one of our equations. Let's go with equation 2. It's completely up to you to use 1 or 2 though. So we've got x is equal to minus 3. We've got plus 2y minus 7 is equal to 0. And we're just solving for y here. So what we're going to do is we're going to, firstly, we can do minus 3 minus 7 is minus 10. So we're going to have minus 10 plus 2y is equal to 0. And we'll just add 10 to both sides to get that 2y is equal to 10, or y is equal to 5. Now that we've worked out x and y, we can say, so the point of intersection, it's always best to write this, just so you know exactly what point you've worked out. The point of intersection is negative 3, 5. And this is just our first way using simultaneous equations. So here we have a bit of a more exam style question. It's a pretty big question with 3 parts to it. Although using the things that we've learned so far, we should be able to do all of it. So this is the type of question that you might find in an exam, and it says triangle PQR has vertices P, which is the point 8, 3, Q, which is the point negative 1, 6, and R, which is the point 2, negative 3, as we can see, and they form the triangle. Now our first question, question A, asks us to find the equation of the altitude of QS. So we'll do that first. Remember, the altitude goes from a point on the line RP, in our case it's S, and it goes perpendicular straight up and meets QS. We've got, we want to find the equation of the median RT. So the median RT, as we remember, goes from one vertex, R, to the midpoint of another line opposite it. In this case, it's PR, meets at the point T. And we're told, hence, find the coordinates of M. And we can see M is the point of intersection of the lines RT and SQ. So in order to work out part C, we need to do the equation of the altitude, the equation of the median, and use them to work out the coordinates of M. So before we get into this question, if you need to remind yourself about what an altitude is or what a median is, be sure to check out our videos on that. But let's just begin with part A by working out the equation of the altitude QS. So for the equation of the altitude QS, we know we need to use a point on the line, which we already have. We've got Q. So we need to work out the gradient of this line. And what do we know about the altitude QS? Well, we know that it's perpendicular to the line RP. So we can use our fact about perpendicular gradients to work out that gradient. So we'll start off by working out the gradient of RP, which we're going to get y2 take y1 over x2 take x1, which is going to give us, well, the y coordinate of P, is going to be 3, and our y1 is going to be the y coordinate of R, which is minus 3. This is all going to be divided by the x coordinate of P, which is 8, subtract the x coordinate of R, which is 2. So we're going to get 6 over 6, which is very nice because it just gives us 1. So therefore, we can use our facts about perpendicular gradients by saying, so the perpendicular, the gradient of the perpendicular line, which is the line SQ, and we're going to say that this line, because it's perpendicular, is going to be minus 1. And this is because since the gradient of RP times the gradient of SR is equal to -1. So we've got the gradient of the altitude QS. Now we just need to work out the equation of it, and we can do this because we've got a point that lies on the line. So we use y take b equals m x take a. We got y subtract, and our b coordinate is the y coordinate of q, which is 6. Our gradient is -1, we'll just put minus, and our a coordinate is the x value of q, which is -1, so we're actually going to have +1. And now we can work out the equation by doing a bit of expanding. So we get y minus 6 is equal to -x subtract 1. So y is going to be equal to minus x, add 6 to both sides, is going to give us +5. Now I have left this in the form y equals gradient x plus the y-axis intercept, but it's completely up to you if you want to write it in general form. This is enough to get you the mark. If you were to write it in general form, you would simply say y plus x minus 5 is equal to 0. Both of these are fine. So moving on to part B, although it's important that we keep our answer for A, so I'll bring that back when we go on to part C. But for part B, we want to find the equation of the median RT. Well, what do we know about the median RT? We know that it meets at the midpoint of the opposite line. So we know that T is the midpoint of the line PQ. So let's work out the midpoint of PQ, which we're actually calling the coordinate T. So this is going to equal x2 plus x1 divided by 2 because it's halfway, plus comma y2 plus y1 divided by 2, which in our case is the x coordinates and the y coordinates of PQ. So for P, our x coordinate is 8 and our x coordinate of Q is -1. Dividing that by 2, and we'll do the same with the y coordinates. The y coordinate of P is 3 and the y coordinate of Q is 6. Divided by 2, and this is simply going to give us the coordinate 8 minus 1, which is 7 divided by 2, which is going to be 7 over 2. So this time it's not as nice, we're getting a wee fraction, and we're going to have 9 over 2 as the second point in the coordinate. So this is our coordinates of T. So now that we have the coordinates of T, we have a point that which lies on the line, although we already had one, because we had R. So now that we have 2 points that lie on the line, we can work out the gradient of RT. And we're going to use our formula y2 take y1 over x2 take x1. So this is our coordinates of T. We also know that the coordinates of R are, and I'm just going to write them out to make it easier for us to see. So in this case, our y2 is going to be 9 over 2. And our y1 is going to be minus 3. So we're actually going to add 3 because it's minus 3. And our x2, we need to make it consistent with our y2. So it's going to be 7 over 2. And we're going to be subtracting 2. So here we have to do a bit of fractional work to work out what this gradient is going to be. Well, let's make it nice and easy by changing these whole numbers into fractions. So we're going to get 9 over 2. Instead of plus 3, we're going to write plus 6 over 2, which is a common denominator, and 6 over 2 is, of course, 3. And on the bottom, we're going to have 7 over 2 minus 2. We'll write minus 4 over 2. And when we do this, we're going to get 3 over 2 divided by, sorry, not 3 over 2. We're going to get 12 over 2. not even 12, we're going to get 15 over 2, divided by 7 minus 4 is 3 over 2. And what do we do when we divide a fraction by another fraction? What's the same as just multiplying them, the second one flipped. So we get 15 over 2 times 2 over 3, which is going to give us 30 over 6, which is just 5. So we did a little bit of working with fractions here to work out the gradient of the line RT. So now we have the gradient of the line RT, we have a point which lies on the line RT. We can now work out the equation of the line RT by using y take b equals m x take a. Now for our a and b in this case, I'm not going to use the coordinate t because it's a bit messy. So I'm going to use the coordinates r, which still lies on the line. So it's completely fine to use. So we're going to get minus 3, which is just plus 3. Gradient is 5. A is 2. So now we can say here that we're going to get y plus 3 is equal to 5x minus 10. Or we can rearrange this to say that y is equal to 5x minus 3 from both sides minus 13. So we've worked out the equation for part B, which is the equation of the median RT. So now that we've got our answers for A and B, for A we said that y is equal to minus x plus 5, and B, which is the equation of the median, is y is equal to 5x minus 13. Now, as I said, we could have written these in general form, but I have left them in the form y equals, and this is because y is on its own in both equations. We've not got 2y in one and y in the other. We've got y with a coefficient of 1 for both of them. So if we're working at the point of intersection for C, which it doesn't actually tell us it's the point of intersection, but we can see that M is where the lines cross, so we know it's the point of intersection. So we can do one of our methods that we learned earlier, and the method I'm going to go for here is simply going to be equating, because we know that y is equal to this, and y is also equal to this. So we can say that minus x plus 5 is equal to 5x minus 13. And then what we're going to do here is we're going to add x to both sides and add 13 to both sides to get them both on their own. So if we add 13, we're going to get 18 over here, and we're going to get, when we add x to both sides, we get 6x on the right hand side. And this is simply going to give us the fact that x is equal to 3 when we divide both sides by 6. So now what we're going to do is we're going to substitute the fact that x equals 3 into, now we've not called them 1 or 2, so I'm just going to say substitute it into a. So when we substitute it into a, we get that y is equal to minus x, which in our case is minus 3, plus 5, which is just going to be 2. So we say that M is the point 3, 2, which we worked out as we did our equating form of finding the intersection. So that is going to be it for our intersection of lines and working at the point of intersection. So again, we're not always going to be asked to find the point of intersection. We might be asked to find a few things first before we work it out, or we might be asked to verify that that is the point of intersection. A question might say, show that M is the coordinates 3, 2. Well, you can do that just by working them out, or you could do it by substituting the point into one of the equations. But this is just one general style of exam question. And this should be a relatively easy question that should get you some nice, easy marks.